Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for this morning will be December 28, 2023. It's almost New Year. So for this morning, I will be having a random topic. It's still a long video format. It's not so long, but I will place it under long video format so viewers could fully understand the concepts behind it and the importance of this on under study. Okay, let's proceed. We got a problem for this morning. It's a random topic, and this topic is actually refers to this is a part of algebra, but specifically speaking, this falls under analytic geometry. Analytic geometry meaning we are on the so-called Cartesian coordinate system. We are on the so-called x and y axis. It's a part of algebra, but if you took up engineering or if you take up engineering, this will be a special subject and this falls under the so-called analytic geometry. But here in the USA, they try to merge this topic under the study of algebra. Okay, but for me, since I took up my engineering separate from what you call this, the other courses, uh, I've made this, we took up this topic just to study analytic geometry, concentrating on analytic geometry. Okay, let's proceed. We are given the problem. What is the x-intercept of the line that passes through the point? We are given a point. The coordinates of the point is 4 and -7 and has a slope of -1. So it seems this is not a so-called study of algebra. It's analytic geometry. We are on the so-called Cartesian coordinate system, the x-axis and the y-axis. We are given a plane, right? So the problem here, we are given a point and we are given a slope, and the problem is asking what will be the x-intercept. This falls under the so-called study of straight line. So if we try to solve this one, we must have to bring out the so-called one of the standard equations for straight line. And one of the standard equation is the so-called slope-intercept form. If we are given the slope, okay, and we are given a point that passes through that line, by using the so-called slope-intercept form, we could compute for the equation of the required line. Actually, this is the required line. This is the one. Okay? The slope is actually -1/2, meaning the slope here is m is equal to -1/2. It should incline upwards to the left. That's why it's negative. If this is positive, it should slope upwards to the right. Okay, since this slope is -1/2, this should lie down or incline upwards to the left. And this is actually the straight line. It is something like this. If we try to draw the point where that line intersects, it is this point here. If this is the x-axis and this is the y-axis, okay, according to the given problem, the line passes through the point 4 and -7. So this should be 1, 2, 3, 4. So this is 4 units. And -7 should, it's a negative, right? So instead of going up, it should go down. So this is 1, 2, 3, 4, 5, 6, 7. So this length here is actually -7. And the intersection of the abscissa 4 and the ordinate 7 is actually this point here. So the required line passes through this point. This is the required line. It passes through this. And the coordinate of this point is given as 4 and negative 7. Right? And the problem is just asking where does the line passes through the x-intercept or passes through the x-axis. It is at this location here. The problem is asking what will be the coordinates of this x-intercept. And according to our computation, okay, I will just give the answer, but I will discuss the solution later. The x-intercept is actually negative 10, meaning this is 10 units to the left. The abscissa is actually 10 units to the left. This is negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, since this is to the left, this is actually negative 10. And actually, the required line passes through this point here. As per our computation, x is equal to negative 10. But we will discuss the solution. I am just giving you the correct graph of the solution. Okay? The required line passes through the point 4 and negative 7. Okay? It passes through the negative 10 and 0, which is the so-called x-intercept. And this will be the solution. And actually, we could also solve for the y-intercept. The y-intercept is actually this one here. Y-intercept is actually the point where the line crosses the y-axis. It is actually at the location 0 and negative 10. Later on, we'll bring out this one why it is 0 and negative 5. So as you can see, since the line is actually drawn to scale, this is actually 0 and negative 5. This is 4 and negative 7, and this is negative 10 and 0. This is 1, 2, 3, 4, 5, 6, 7. Right? So when we drew it, it is exact that it passes through the y-axis at 0 and negative 5. And it intersects the x-axis, or it passes through the x-axis at the location negative 10 and 0. Okay, let's try to bring out the solution. So this is actually the summary of the solution. But the analytical solution will be this. Okay, to bring out the solution, since we are on the topic straight line, this is a random topic, guys. This is important for you guys who are taking up your SAT or CAT exam. Will it be possible that this falls under the board? It's possible. So if we try to recall the slope-intercept form, the equation is actually y equal to mx plus b. Where m represents the slope of the required line, and b is actually the y-intercept. Okay? Using the point 4 and negative 7, I place it here. This 4 with the coordinates 4 and negative 7 must satisfy the given slope-intercept form. Since this point here passes through the required line, or it is on the required line, this coordinate should satisfy the x and y of the slope-intercept form. That's the meaning of this. That's why using 4 and negative 7, x will be the abscissa, which is 4, and the ordinate will be negative 7. The slope is actually given as negative 1/2. So by using this slope-intercept form, substituting the value of x, y, and m, what will happen? Y will be negative 7. Am I still on camera? Negative 7 equal to m is negative 1/2 the slope. The value of x is actually 4 plus the value of b, small letter b. This small letter b is actually the y-intercept. Why we are solving for the y-intercept? We are solving for the y-intercept because later on, okay, we needed the equation of the required line. So, what will come out? B now will be equal to negative 7. We transpose this to the left. Okay, then we rearrange. So, it will, the y-intercept will be negative 7 plus 2. Or the y-intercept will be b equal to negative 1. I place it here, it is the y-intercept. It is as this location here. the abscissa at the y-intercept is actually equal to 0 and y is equal to negative 5. So the coordinates of the y-intercept is actually at the location 0 and negative 5. It is this. 0, negative 5, 1, 2, 3, 4, 5, negative, it is downward. So the coordinates of the y-intercept is actually at the location, at the point 0 and negative 5. It is this. That's the importance of this. Okay? Since we now know the y-intercept, we could go back here. What will come out? We are now solving the equation of the required straight line. Y now will be equal to negative 1/2 times x. And what is the value of the y-intercept? It is negative 5. Okay, it's negative 5. So, the required equation of the straight line, which passes through 4 and negative 7, is actually y is equal to negative 1/2 of x minus 5. And how would we compute for the x-intercept? At the location of the x-intercept, what's the value of y? Y is actually equal to 0. Okay? When it passes through the x-intercept, the ordinate at the x-intercept is actually 0, right? So y will be 0. So if we try to place y equal to 0, what will be x? We could compute for x. And this x here is actually the x-intercept. So by using this equation here, okay, to compute for the x-intercept, we will set y equal to 0 and we could compute for x, and that x is actually the x-intercept. So 0 now, we place y to be 0 equal to negative x over 2. Okay, for the meantime, we do not know the value of x. We are solving for x minus 5. We transpose this to the left, therefore x over 2 should be equal to negative 5. So x now will be equal to negative 10. We'll just multiply this one by 2. So this one here cancel with this. X now will be equal to negative 5 times 2, or this will be negative 10. So the location of the x-intercept is actually at negative 10 and 0. It is this. It passes through the x-intercept at the location negative 10 and 0. 1, 2, 3, 4, 5 up to negative 10, and the ordinate is actually 0. So our answer here is the x-intercept is actually negative 10. Okay, that's it, guys. This is just a good example of a problem under analytic geometry, and this falls under the study of straight line by using the so-called slope-intercept form. Okay, good morning from Los Angeles, Professor David J. De Los Reyes. Still Merry Christmas and advance Happy New Year. Good morning.